Hello, so in this video we're going to work on the second worksheet posted in Google Classroom, which has more examples for parabolas. We've already been through this before, but let's have just some different examples. In this worksheet, first we have to graph a parabola and identify some parameters or some variables. In this worksheet, we're going to find the vertex, directrix, focus, and axis of symmetry using only the equation of the parabolas given. So we're given an equation and we need to graph this equation based on the parameters that we're going to find. So let's just pick one of them, one of the examples. Let's start with number 3, for example. Okay, number 3. The equation is x squared equals 12y. Okay, I kept this from the previous video, which shows us the, the the vertical parabola and the horizontal parabola and how they are going to look like, the two cases in each, and how the equation, the general equation, looks like. So first let's just compare this to the equation to see if it's a vertical or a horizontal parabola. And if you guys just forgot about this formula, you can just again, you can use common sense. So here we have the square, the power over x, not over y, which means every single time you have one value in y, you're going to have two values in x, which means the parabola is either going to look up or down, which means it's a vertical parabola. Another thing, the factor here multiplied by y is the factor multiplied by y is with a plus sign, which means the vertical parabola that you're having is an opposite, is a positive, vertical parabola, which means it looks up. Anyway, let's just start with having the parameters, and then we'll see how this actually works. First, so let's just write down what we're going to find here. We need the vertex, we need the focus, okay, we need the directrix. Let's just write them later. Let's start with these two. First, we're going to find the vertex. To find the vertex, we're going to again use this general formula. So here we have h and k, which are the coordinates of the vertex. Now here, what is h in this case and what is k? Here we have x only, x squared. We don't have any number with the x in here, which means it's originally x. Basically, it's x minus 0 squared. Okay, and then it's equal to 12 multiplied by y minus 0, and that's it. So the h and k that we have is, so the vertex is v 0 and 0. That's the x, that's the vertex. By the way, what we did before in school was we had two different tables which were in the book, if you remember. One of them was for the parabolas with the vertex at the origin, which means the vertex is 0 0, and then we have another case when we have this vertex shifted, so we had the h and k. But basically you don't have to memorize both tables, it doesn't make sense. You just have to know the second one, which is with h and k, but when you apply h and k as 0, you get this. Okay, now the focus point. To get the focus point, we need to find p, which is the distance between the focus point and the vertex. So p, here again, here is our general formula. Here we have 4p, which is multiplied by y. Now the number multiplied by y here is 12, which means 4p is equal to 12, which makes p equals to 12 over 4, which is 3. So the distance between the focus and the vertex is 3 steps. Okay. Now, if we have already we have our vertex at 0, 0, okay, and it is a vertical parabola. Let's use a squared. Let's use this paper to do this. Okay, so let's put this a bit up. Okay, first we already found that our vertex is 0, 0, so it's right here. Okay, and then we had the focus at, oh, we only had that, we only knew that P is 3. Now, we already said it's a vertical parabola. It's a vertical parabola, okay? It's like this. So when we're going to find, we're going to move 3 steps, are we going to move right, left, downward, or upward? Now this is the question. Since it's a positive number here and it's a vertical parabola, first it's a vertical parabola, which means it's either going to move up or down. It doesn't move right or left. So moving up and down now leaves us with the sign of the factor multiplied by y. Now p is positive, which means it's going to move up. So the focus is upward. The focus is up here. So we're going to move 3 steps up. So we have 1, 2, 3 steps. So it's right here. This is the focus. So what is the point of it? What's the coordinate here? Here we have x at 0 and we have y at 3, which is p. So here the focus, this is how we write it. You write f, then bracket, and then 0, 3, which is the coordinate. Okay? Okay. So basically this is just an approximate of how our parabola looks like. Now we want the directrix. We said to make this, to call this actually a parabola, the directrix have to be in the same distance between the focus and the vertex. So if this is here, right here, if this is V, this is V, okay, and this is F for the focus, the directrix, here we went up 3 steps, which means the directrix is 3 steps down from the V. So we have 1, 2, 3 steps right here, and this is the D, let's call it just D. And when the parabola is vertical, the directrix is horizontal. When the parabola is horizontal, the directrix is vertical. Here we have a vertical parabola, which means that we have a horizontal directrix. So just going to draw a line that crosses this point, which is my -3 in the y-axis, and this line is parallel to the x-axis. Okay, so here we found the third thing here that is needed, the third parameter, which is, okay, we found the vertex, we found the focus, we want the directrix right here. The directrix is, okay, we write it as a line, as a linear equation, which is y equals -3, which is negative p, because p is up, which is the focus. We went down like we showed in the graph, so it's y equals -3. The last thing needed here is the axis of symmetry. The axis of symmetry is the line that basically divides the parabola into 2 equal halves. So here it's like the mirror of the parabola. The line that crosses this parabola into half always, okay, it is always the point that doesn't change between the focus, vertex, and even the directrix. Now here we have one point that never changed. If we write this as coordinates, v is 0, 0, And if this is just a point that we're talking about, just a point, not the directrix itself, not the line, just a point. The point is 0, -3. We can see here that the x-axis never changed, the coordinate of the x-axis never changed, which is 0. So the line, the axis of symmetry is a line that is called x equals 0, which is the y-axis itself. So the axis of symmetry here, axis of symmetry is x equals 0, which represents the y-axis, because the y-axis in this case is the line that divides the parabola into two um, equal sides, let's say. Okay, let's have another example with different case. Uh, okay, let's try number 7. Here, number 7. Okay, please follow from the worksheet that you have already. Number 7 is y plus 3. It is y plus 3, that's squared, equals 12 multiplied by x plus 1. Okay, I hope this is clear enough. Now, in here, I'm just going to do this so we don't miss this. Here we need to find the same things: vertex, focus, directrix, axis of symmetry. Let's start with the vertex, which is finding h and k. Again, I'm going to go back to our original equations right here. Now, which one does this look like? It is the second one, which means it's a horizontal parabola. And here we have the 12 as positive, so we have a horizontal parabola that is facing the right side of the plane. So here, first let's just find h and k. This is h and this is k, right? Or no, sorry, it's vice versa, because here it's horizontal. So whatever is with the y is k, okay, whatever with the x is h, because as we said in the book, in the linear equation, quadratic equation, absolute value equations, in all of these lessons that we took before, we always use the same parameters: h for the steps moved in x or the shifted in x, and k for the steps shifted in y. Okay, now let's find a vertex. Vertex, which is v, is h and k, which is, now what is h here? It's not 1, it's -1, because in the original equation right here, it's supposed to be negative, and since it's positive here, that means we already had the negative number that made the sign become positive, because negative is positive. So here we're having h and k that is -1, and the k is the same case here, which is -3. So this is our vertex. Okay, let's start graphing this so it becomes easier for us. Okay, so the vertex is -1, -3, -1 in the x, which is here, -3 in the y, which is here. So this is the vertex, and we already said that the parabola is looking right, so it's a positive one. So here we already had the vertex. Let's see what the focus is. Focus f. The focus, again, we need to find the value of p. Now here we have 4p, that is equal to 12. Okay, that's just a coincidence, it's the same thing as before. So p is equal to 3 again, So we have three steps, but just this time it's moving, it shifts right side, not upward like before. So right side means that here we're going to move from the -1, we're going to move 1, 2, and 3. And this is the focus right here. What is this point? What is the coordinate of this point? We're going to see here. We have 1, 2 in the x, and we have 1, 2, 3 in the y. So it is 2 and -3. And here the coordinate here is -1 and -3. As you can see here, these 2 points, the difference between the -1 and 2 is 3 steps. Okay, so the focus here is 2 and -3. Okay, now let's move to the directrix. The directrix. Okay, the directrix is, we usually do this, like we said before, as a linear equation. Now let's see. The directrix has to be the same steps away from the vertex as the focus. The focus is already 3 steps away from the vertex, but on the right side. For the directrix, it's going to be in the other side, which is the left side. So we're going to move left 3 steps. So we have 1, 2, 3. Now let's see what is the coordinate here. We have -1, -2, -3, -4. So the point that this line crosses is -4 in the x-axis. So it's -4. Okay. Okay. Sorry, I didn't. Here. Now this is a line that crosses the x-axis, and it is parallel to the y-axis. Now how do we write this as a linear equation? We say x equal -4. So this is our directrix equation. It is x equals -4, which is basically found by doing this. It is -1 minus, this is the -1, which is the point where the vertex is. Because we're moving left, we're going to negative it 3 steps. So -1, -3, which gives us -4. That's if you're doing it without graphing. Okay, but graphing always makes it easier. And then we have the last thing, which is the axis of symmetry. Okay, for the axis of symmetry here, again, we're going to look at the point. Like I said before, it's just a trick that you can use. Look at the point that never changed. Here, what is the point that doesn't change in all? I mean, especially if you're doing this without graphing, again, just check the point that doesn't change with changing the parameters. Here we have the vertex. As you can notice here in the y coordinate, we have -3. In the focus, the y coordinate is -3. So the axis of symmetry is -3. It's a line that crosses the -3 on the y-axis, which means it is a line that is called y equals -3, which is this line right here. Here. This is the axis of symmetry. Okay. I have these examples made it clearer for you. Please solve the rest of them. Try to make it to graph all of them and find all the parameters, and let me know if you had any problems with this worksheet so we can make another video for it. Okay, the next video will be for the next lesson that we took before. So we're going to revise the solving linear equations using using matrices, and using substitution, also using elimination. Okay.